continuation, we have example number 4. Okay, for example number 4, what if there was a fabrication error? So you're now asked to determine the joint displacements, member axial forces, and support reactions for the given truss shown. Same figure like what we had from example 2 and example 3. And the support reactions for the given truss system. Due to the fabricated lengths of members 3 and 4. Note, members 3 and 4, yung merong error. That are 1/4 inch too short. So, mas maikli daw siya ng 1/4 inch sa field. Maybe because of temperature change. Maybe because of steel expansion or temperature expansion. So 1/4 inch too short. Use the matrix stiffness methods. Everything is just the same, no? Pare-parehas lahat. But we'll just have to change a few things, especially on member 4. Following this condition, okay, elements which has a fabrication errors as shown here. Ito yung ating notes for fabrication errors. So if we have an element or within our truss system which has a fabrication error, it's like in our example, if a truss member is made that is too long by amount of delta L or the change in length, before it is fitted or bago natin siya ilagay, okay, into a truss, then the force Q needed to keep the member at its design length Q equal now to the stiffness times the change in length. This force will hold the joints of the member fixed as shown. Parang i-hold lang niya based on with the fabrication errors. So ano yung effect nung error na yon with our truss? So sa example 3, meron tayong deflection sa node. Pero ngayon, basically, merong deflection exactly on the local coordinate system of the member. Okay, which are on member 3 and member 4. Following, so we need first to identify the force at such member by simply multiplying the stiffness EA over L times the identified change in length, which whether they are too short or too long. If it is too short, that will then be designated as a negative value. Too long, so positive. Then multiply it on the matrix of 2 by 1, which is a positive and negative 1. As I've already said, if the member is originally too short, then delta L becomes negative, and these forces will, of course, reverse. Then we'll have to compute the equivalent forces on such member due to that error or due to that fabrication error by multiplying the transpose transformation matrix of such member with the Q value of such member, which gives us EA over L times delta L times the matrix of 4 by 1 cosine theta, sine theta, negative cosine theta, and negative sine theta. Okay? Okay. Dire-diretso tayo, no? So, member 1, ganun ulit. Solve nyo yung local stiffness, transformation matrix, global stiffness matrix of each member up until to member 5. And bago ka mag-move sa general global stiffness matrix of the truss, solve muna natin yung elements with fabrication error. First thing here is considering member 3, which has a too short a length of 1/4 inch, so negative 0.25 inch. So negative 0.25 inch is your delta L. Ano yung stiffness ni member 3? EA over L is 250. Then compute for Q. EA over L times delta L times this matrix. Kaya na lang mag-multiply niya. Scalar quantity multiplied to a matrix, so cell to cell. Okay? So it's negative 62.5, negative 62.5. Then multiply that on the cosine theta, sine theta, negative cosine theta, negative sine theta of member 3. Gives you the forces along member 3 on its global coordinate system. Okay? So remember, member 3 is what? Node 3 to node 2. Huwag kakalimutan yung near-far condition nyo. Pag pinaliktad nyo yung near-far condition in one of the members, either of the procedure that has been introduced, of course, definitely you will come up with a wrong answer. Kaya nga nilagyan natin ng arrows para hindi magkanda bali-baliktad. Okay, so yan na yung ating U3, V8, U4, and V5 of member 3, considering a 2 short of 1/4 inch. Same goes for member 4. Delta L, negative 0.25, EA over L, 173.3. Multiply, then times. Gives us Q of 43.3 and negative 43.3. We multiply that with positive cosine theta, sine theta, and negative cosine theta and negative sine theta. Following the near-far condition from member 4, U6, V7, U1, V2. Ganun ulit. Ito yung ating values. Then, arrange it as follows. Ito ngayon yung bago sa inyong structure or partition matrix. Fix end forces for the members of trusses due to fabrication errors on its length or of the lengths. Okay? So, ito yung nasa member 3, member 4. I-arrange lang natin siya sa PF1 to PF8 as shown. Ito yung effect adjustment force natin doon sa ating truss system. Given kasi that member 3 and member 4 is a 2 short member. Hindi natin sila mapag-fit doon sa ating truss system. So ito yung adjustment pagdating sa force at saka sa deflection natin later on. Ito yung magiging adjustment na i-introduce natin. So PF1 to PF8. Arrange nyo lang by number. So we have here 1, 2, 3, 4, 5, 6, 7, 8. So arrange nyo lang by number. Then copy this value so that we can add them up with our general global stiffness matrix. So as a general formula, considering a fabrication error, that is, the P forces equal now to the structure matrix times the deflection plus the adjustment force, PF. Okay? 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 Okay. Hello? Okay ba? O, ganon. I-add lang natin. Marami talaga. Ang daming variables. Okay. Same partition. Your known forces, your unknown deflection, and your known deflection. Then your adjustment force. Then, ganun ulit. Identify your joint load matrix. So with this given example, hindi tayo nag-introduce ng applied force. So basically, P1, P2, and P3 are all zeros. Okay? Yun lang. Tanggalin lang natin yung forces. And the known deflection, ganun pa rin. Zero pa rin sila. Dahil wala namang impending settlement, wala namang known deflection sa support, and so forth and so on. Okay? So, 0 pa rin si D4 to D8. And P1 to P3 are now zeros. So, para sa adjustment, ito na ngayon yung ating bagong formula. For the augmented matrix for deflection, that is now equal to the known forces, P1 to P3, equal now to the matrix S11 times the unknown deflection plus the matrix S12 as shown. Tignan yung coloring. Binigay ko para madaling makita kung anong section yan. Ito yung S11, ito yung S12, ito yung S21, ito yung S22. Okay? Then, multiply it with the known deflection. And lastly, add them up with the adjustment force for P1 to P3. Okay? Nakita kung saan nakuha yan? Nakita? Hello? P1 to P3, 0. This, yes. Then this, multiply the D4 to D8, plus ito, PF1 to PF3. So simplify, that is basically 0. Diba? 0 na yan. Then, transpose natin to dun sa kabila. Giging negative, which is this one. Then, divide it with this matrix. Eh, wala namang division of matrix, which is, gawin na lang natin inverse. So, inverse of matrix S11 times this matrix. So, ito ngayon, yung bagong deflection natin. Considering a fabrication error with member 3 and member 4 of 2 short 1/4 inch. May na-introduce lang na bago. Everything is just the same. D1 to D3. Then, same goes in computing the unknown forces or unknown reactions at the support. So the unknown reactions at the support, that is now your S21 matrix times the unknown deflection D1 to D3 plus your S22 matrix times the known deflection plus the adjustment force PF for D4 for PF4 to PF8. PF4 to PF8. Yung na-solve natin kanina, eto, tignan mo yung kulay. S11, S12, S21, S22, eto. Kasi, dapat confirmable. Kung 5 rows yan, dapat 5 rows din dito. No. Yan yun. P4 to P8. PF4 to PF8. So substitute there. Multiply this. So simply that is 0 now. Multiply 5 by 3 matrix with a 3 by 1 matrix. There's now a 5 by 1 matrix plus a 5 by 1 matrix. So add lang natin sila. Basically, kuha tayo ng 5. Multiply a 5 by 3 matrix with a 3 by 1 matrix. Then, add them up. Add it up with this matrix. Okay. Then, yan. Parehas ba? Parehas yan. So, yan na yung ating reactions at the support, knowing that there is a fabrication error for member 3 and member 4. Nakuha kung paano nakuha yung forces. Yes. Yun naman, basta may ano pa. Pero syempre, diba, you're a student, alam nyo naman yan. Mga pwede kayong gamitin na iba to solve a matrix problem. Halimbawa, Python, if you know how to use Python, you could definitely use Python, solve trusses using a matrix analysis method. Or if you're familiar with MATLAB, you can also use MATLAB. Ito, hindi na ata na-introduce yun sa old curriculum, yung MATLAB. Kailangan yun sa bagong subject. Yun, kung kaya nyo gumamit ng MATLAB, you can solve matrix problems with MATLAB software or Python. Kung alam yung a program, syempre, meron akong program noon. Syempre, hindi ko rin ibibigay. Yan lang naman yan, no? Then, same in solving your end displacements and forces. Your end displacement under global coordinate system from number 1, 2, 3, 4, and 5. Transformation ng end displacement into a local coordinate system. Then solve for the forces by multiplying it with the local stiffness matrix. Okay? Hindi mo na kailangang i-apply yung negative 0.25 ha. Baka i-add nyo pa doon sa end displacement of local coordinate system yung fabrication error na 1/4 inch sa member 3 at member 4. No need. Kasi naisama na natin siya doon sa computation doon sa ating PF forces tsaka adjustment ng ating deflection. So, ayan na yun. Part na siya. Hindi mo na kailangang i-add yan. Kaya baka i-add ninyo. Iiba yan. So, just the same. Just like what we did on example 3, 2, and 1. Yung solution ng member and displacement forces and forces, ganun pa rin. Ang naiba lang is that the computation for the deflection as well as the reactions at support. Okay? And one thing new here is member 3. Yung addition ng force QF natin. Okay? So remember, may fabrication error sa member 3 at saka member 4. Okay? So yung Q force na na-compute natin kanina sa member 3, i-add lang natin siya dun sa product ng local stiffness matrix with the end displacement under local coordinate system. So add nyo lang. Add nyo lang, then meron na tayong force sa member 3 and member 4. Plus QF. Yan. Oh, baka tanongin nyo saan nanggaling yung negative 62.5. Yan yung kinumpute natin kanina. Sa member 3 at saka member 4. Ayan o. Yan no. Then, i-add lang natin yan. Yan kasi yung adjustment force nung nasa member 3 at saka nasa member 4. Then, yan, ito na ngayon yung actual force ng member 3 at member 4, which are both in tension. Then, the rest are in compression. Tapos, parehas na yung solution sa member 5, 2, at saka 1. Question. So, reviewin na lang, no? So that's your example problem for a fabrication error. Then with deflection, paano kung magkakasama na lahat yan? Tapos with temperature changes. Tapos, paano kung gawin nating 3D? No. Yung space trusses. So that's your example problem with fabrication errors. So try to solve the same problem. What if there is now an introduced settlement or deflection? So it's just the same, right? Then, dagdagan nyo lang yung solution based on the condition given. Now, bigay ko naman yung formula. Step by step pa yan. For fabrication errors, ayan ulit. Ito lang naman yung nadagdag na formula. Then, i-add nyo lang yung Q dun sa computation ng member forces. Question? Concerns?